Hello everyone, in this video I'd like to introduce how can we set up the Beckhoff ADS communication between Beckhoff PLC and the Siemens i7 1200 or 1500 PLC. As we know, the default communication from the Beckhoff PLC controller, it is ADS, its full name is Automation Device Specification. Before this solution, if we try to set up the Ethernet communication between Beckhoff PLC controller and Siemens PLC, basically we have three solutions: Profinet communication, TCP/IP, or Modbus TCP. These three solutions are based on the Ethernet communication. However, all of them, we have to purchase the software package from Beckhoff. And all those solutions, I had the video in my channel before. So to find out the solutions, if you go to YouTube and search my channel, Electrical Automation Hands-On, and then go to posts. And I have this post from 2024 October. This is a summary about the videos in my channel talking about the communication between Beckhoff with any other brands, the main brands. For example, the typical communication solution, TCP/IP, Modbus TCP, server client, right? Ethernet IP, typically this Allen Bradley CPU, and the Profinet, Siemens communication method, Profinet, or the OPC UA. Okay, so I had those solutions already, and you can find this post from my channel, and you can find all those links. I will also copy those links under this video. However, all those solutions, it need the TF63 or 62 something. So those are the software package you need to purchase from Beckhoff. For example, TCP/IP is a TF6310, and Modbus is this, and Ethernet IP is this, and Profinet is this. You need to purchase, but now in your system, if you have to set up the communication, Ethernet communication between Beckhoff TwinCAT3 controller with Siemens 1200 or 1500 PLC. With the solution discussed in this video, there's no any additional cost. This solution provided from Siemens, and you do not have to purchase anything. This is for free, and you can download this example program from Siemens support website. And in this video, I will demonstrate how can we implement this. And this ADS default come from Beckhoff TwinCAT3 controller, and it's very easy. In addition, so Siemens provide all those methods, as we can see, bool, bytes, word, dword, and rail and long rail. All those data types are versatile, so they are very convenient, and you can implement those features just within half an hour. Okay, please follow me, and let's firstly go to Siemens support website, support.industry.siemens.com, and then you search this ID 1099865531. This solution named ADS block for Beckhoff communication, and the key feature, the key function block from this example, it is read underscore ADS function block and write underscore ADS function block. So this example started from version 18. You have to use TIA Portal equal or above version 18. Okay, this applied the library and this example. And in this case, I will download this example. And based on this example, I will replace the PLC, the CPU type into my actual CPU hardware. And inside this example project, it has 1200 PLC and 1500 PLC. And before we implement this project, I highly recommend you download this document. And let's open it. It is named ADS block, so supplied from Siemens. Okay, and we can see it has read ADS and write ADS, these parameters, how that works. More importantly, it also includes the error code, because one thing I like to introduce is I implement this feature before this video, and I found actually the sample program, it has some glitches. So if you directly use the sample program, you can now implement it successfully. So please follow me, I will correct that. And before I correct, I definitely like to show the error. How can I correct the problem based on the error code? Okay, Beckhoff side, the Beckhoff controller, it is using TwinCAT3 3.1, the runtime. Okay, keep in mind this. Okay, it has a library and the example project. 2 function block. One is a read ADS, one is a write ADS. But in the example project, Siemens actually did a very great job. Instead of just providing this 2 function block only, Siemens actually set up a program. That program cyclic run, and the Siemens PLC communicate with the TwinCAT PLC controller with multiple variables. As we can see here, this is the one variable name instant. This is the bool. But in the real case, so if we scroll down here, from Siemens example project, it actually can communicate with all those variables. Keep in mind. So basically from this area is a single variable for testing purpose. But this area, bool, bytes, word, dword, integer, int, and real. Typically, if you have one project and the project need to communicate with some data across the 2 different brands via the ADS communication, this solution you can directly use. It had everything inside. It's very convenient. But there are some glitches. I will demonstrate how can we troubleshoot this, and we will fix that. Okay, so now, and I will download the example project, and let's step by step implement this. So from the Beckhoff side, we need to implement the variable tag. So inside that PDF document from Siemens, it supplied all those tags we can copy and paste. And other than this, we need to identify the IP address of the Beckhoff PLC, the controller IP address, as well as the ADS NAT ID. So this is the ADS ID. So I will show how can we check out this. In this case, I will use my computer running as the Beckhoff PLC. And it is a local IP and a local NAT ID. But in the real case, you might have a real controller. This is the Beckhoff PC. Is running TwinCAT runtime. We can remotely check the ADS NAT ID. Okay? So this is the target. And locally here, we are using Siemens 1200 PLC. And the parameter for the connection behind here, we need to set up those target IP address and the NAT ID, as well as the ADS local the ID here. Okay? This is the structure, the overall picture. Now, let's firstly go to the TwinCAT system, and I will set up the project starting from the scratch, and I will copy all those tags. Let's use a couple minutes set up this TwinCAT project. Okay, this is my TwinCAT engineering system, and I will use this computer download to locally to run as TwinCAT PLC. Okay, so I will open this XAE. Okay, let's run as an administrator. Okay, let's set up a new project. Okay, I will set up this TwinCAT project. Let's name the ADS with Siemens. Okay, ADS with Siemens. Okay, let's create. Okay, we create this project, and then let's set up a PLC project. Add a new item. Okay, let's call that PLC1. All right, we set up this empty PLC project. And now let's go to license. So in this case, I'm using my laptop running as TwinCAT PLC. Okay, so here, default is using TC1200, 100% in every project. So you have to use TC1200. This is the TC3 PLC function. Okay, so you can click a 7 days trial license. So your TwinCAT3 PLC is your runtime license. Okay, and now we are using 7 days trial license. So even though we are using our own laptop computer, so you can still able to try this feature. Okay, run the TwinCAT3 PLC. Okay, so I active this trial license, and then let's go to runtime. Make sure your laptop PLC, the CPU, one core can run your PLC feature. So in this case, I will firstly read from my target because I know my computer has 4 courses, and I set one isolated core running as this TwinCAT PLC core. Okay, And if this is the first time for you to set up this, so you select the isolated core and select the set. Okay, so check out your CPU, how many cores is from your CPU, and you can select this, set this, and set. Before you click this set, make sure you save your project. Okay, and then click this set. Then your computer need to reboot. Your Windows system need to reboot. So this is some basic operation. I will now introduce two details here. Okay, so we select this isolated, and we will run the PLC using this isolated core. Double check this task. Okay, the PLC task, we are using 10 milliseconds. This cyclic tick. Okay, so this is the basic system. And then let's double check one thing. Go to the routers and go to the net management. And in this case, I'm going to use my computer running as TwinCAT3 PLC. So I have to check this local net IT. It is 192.168.1.210. So this is my net ID. And if you are using a Beckhoff computer or any other computer running as a Beckhoff PLC remotely, I mean in another computer, so you have to check your remote. You can click here, add, or you can go to your right corner and select router and select this edit routers. Okay, this is the very standard way, allows you to use this TwinCAT platform to connect your target PC, right? Click here, click add, and make sure you know your PC login username and the password. This is the very important. So for example, I have one computer that named desktop-sync IPC. So its IP address is 192.168.1.130. I used this PC before, and its AMS net ID is this. So if your target TwinCAT PLC is this, you have to write it down. Okay, this is your real target, the net ID. So from Siemens PLC side, it definitely needs this ID address and this IP address. One is ID address, one is IP address. Okay, we need both. So in this case, my side, my local net ID is this, and my PC computer, the IP address, my local IP address is 192.168.1.199. My computer username is automation, and my password is 123456. Okay, and IP address is 192.168.1.199. Okay, I summarize this at here. Net ID is 1.210.1.1. Okay, this net ID you can also change it. Okay, this is router's ID address. Then let's go to PLC. Okay, so PLC side default from the PDU program area, we have a main here default. For a quick demonstration, I will not set up any other like variables from the GVL anymore. I will use this default main. Okay, let's go to Siemens document. Let's copy all those variables. I will use the same, the main. Okay, and I will copy all of those tags. Copy. And let's paste here. Okay, we paste here. Let's use tab. Okay, and let's save it. Now we can download this project into my local computer, and we can turn on this controller, and we can test that. So now let's compile, build a project, and I'm going to download. Okay, we build the project. Now let's active configuration. Okay, let's restart into run mode. Okay, we download the hardware. Okay, we have one error. Let's check out. So, okay, it's showing the TCP/IP server. No license, doesn't matter. In this case, we are using the default ADS. We are now using the TCP/IP server. So I can click the clear. Okay, no any errors. And now go to main, and we can log in the program. Log in. Okay, now my TwinCAT PLC is running. And those are the variables running under the main. We can see plc1.main. Okay, and we can also expand, and we can see default now those variables are 0, and this test bool are 0. So we can set a value here, and we can also set an integer. For example, we can set a 10 just to prepare. Okay, and let's write this value. Okay, so we set this bool, and we set this integer here. Now, basically, from the TwinCAT area, we prepare all those variables. That's it. Okay, and this area are arrays. So it has a lot of variables here. And basically, Siemens set up this as a maximum length of this protocol behind from the ADS. Okay, we prepare everything, almost 0 efforts, because all those settings, all the default from TwinCAT3 project, right? Literally, we just copy all those variables prepared here. Okay, now we just save it, and from now we can switch to Siemens side. The Beckhoff side is done, and now we will download the example project. We will use one real Siemens S7-1200 PLC for my test, and my PLC address is this, and I will set up the ADS net ID to 1.220.1.1. Okay, this is my PLC, Siemens PLC side, the local, the ADS net ID. Okay, and let's download this example project. Okay, I download this Siemens example project, and I will copy to a folder, and we will, as we can see, this is the compressed project from version 18, TIA Portal version 18. So I will open TIA Portal version 18. Okay, let's unzip it. Okay, let's open TIA Portal version 18. Okay, now let's click this. Okay, let's find out this compressed file and click open. And then the system will ask us to select the one directory, and we will deploy this project. Okay, I will select this directory. Okay, it is opening this project. So we have this compressed project, and now I just unzip this project. So this is the real TIA Portal version 18, this ADS project. Okay, and let's go to project view. So as we can see, to implement this ADS communication, Siemens supplied the 1200 PLC example and 1500 PLC example. Those examples, Siemens select the safety PLC, but in the real case, it doesn't matter the safety or not. So you can just replace to a CPU that fit for your project. Okay, I will copy this project. I will leave this two sample project as a reference. I will copy and paste. And then I will replace that project, the CPU, into my CPU. Okay, so my CPU, I know it is 1214. So I will change this. Okay, EAH, I will change this name. Now I will work on this project. Okay, everything copied from here. Okay, now let's go to OB1. Okay, it only needs one function block, and DB3 is an instant DB. And the PLC1 is a parameter DB. If we go inside, and we can see this is the parameters DB. And now if we open this FB3, Siemens actually programmed all of those read and write, and for all those data type, for single bool, integer, dent, real, string, and as well as the arrays, bool array, byte array, word array, udent, integer, dent, and the real arrays. So Siemens actually prepared all of those for us. In addition, in every data type, for example, for this real array here, it also includes write and read. That means when this program is running, it is doing the circulating. So from the top to down, or basically it is running the case. So we can see here is a constant. It's running the 0, 1, 2, 3, 4, 5. It goes through this way. It will cover all those state types. Definitely this entire communication, it need a couple of seconds. But in the real case, delete something you do not have to use it. And just need to modify a little bit for this FB3. For example, if you look at here, this is the index number 58, right? This is a real array. And when this ID number equal to 58, so it jump to here, and default, this internal case is 0. So it will do the write. Write for what? Write this real array. This is the TwinCAT tag name. If you recall, from the TwinCAT set, we set up all the variables under the main.plc1 real array, right? This is a real array. Okay, and then once it finishes the write, once it write down, it will write this 10 integer into this internal case, and then this internal case, once equal to 10, it will start doing the read. Okay, once read done, then it go to 0. Set this to 0. Meanwhile, it will prepare the next one from 58 will do the 59 here. 59 long rail it is here, right? 59. So it's like a daisy chain. So once it finish this rail and do the long rail, so this from the top to down, this whole area, it will do the entire cycle here. It's cycling here. So this is the whole task. That means once we set up the communication successfully, this ADS communication, we can do all those variables for the ADS communication. Okay. However, the drawback is if inside here, once this chain somewhere has something wrong, this chain will be broken. So I will correct that. I will demonstrate this. Okay, Siemens did a great job set up this chain for us. It's very convenient. Great job. And here, for the ADS communication parameter, it is under the connection info. As we can see, this is a comments. So how can we set up those connection parameters? It is under the PLC1, this DB. It is DB1 here. Let's open it, and this is connection info. From here, we can see local ADS NAT ID, remote IP, and the remote ADS NAT ID. And more importantly, we can see the username, password, as well as the hardware interface. So this, I like to show this very carefully. Let's step by step. I will demonstrate how can we correct this fit for our application. Currently, we haven't changed anything yet. I just quickly go through, right? After we copy this project, the first things we will replace the hardware to fit your real hardware. So in this case, okay, and here, and let's scan it. Okay, as we can see, my PLC IP address is 1.174, and it is 1BG40. Okay, this AC/DC relay, and its firmware is a 4.6. Okay, now I will replace my offline PLC change device. Okay, and now go back to the project. Okay, here, go to the device configuration, and I will replace this device to my PLC. It is AC/DC relay. Okay, 1BG40, and the firmware is 4.6. Okay, click OK. Okay, so I will set up this safety. Basically allows us to can do everything. Okay, full access and finish it. Okay, once we replace the CPU, you will find your program will show an error. Okay, don't worry. Once we compile, this will be solved. So if now you go to update your interface, it doesn't help. So we have to compile your entire project So it will automatically fix that. So no worries at all. Okay, and because I'm going to download this project, so I will set this IP address, correct it to our case. My case 192.168.1.174. Okay, and enter. Okay, set up this IP address. Okay, then go to System Constant. Click this network port. So you will see for my Ethernet port is a hardware identifier. This number is 64. And its name is a local Profinet underscore interface underscore 1. Okay, so if I float it, and firstly, let's go to this parameter from this DB1, PLC1, this DB. And if you recall, the first one from this connection info here, this local Profinet underscore interface underscore 1. This is this parameter from this port parameter. Okay, as we can see here. It need to be exactly the same. Okay, this means we need to tell this function block which physical port, Ethernet port from the controller you are going to use. Okay, we set up this IP address for my PLC, and now let's firstly compile. So to fix this, okay, so we compile this project, and it will correct this compiles behind. Okay, as we can see, this error gone, no any errors. Okay, now let's go to the connection info. And now again, I just explained this. Okay, connection ID. So what does it mean, the connection ID? As we can see from the right side, this is the one connection ID from the PLC side. From the Siemens side, for any like open Ethernet communication, TCP/IP and UDT. So you need to assign one connection ID for that communication. So default, it is 258 here. We can use this default, especially if there's no any other TCP/IP and the UDT communication from your project. So we can use anything between this number. Doesn't matter. As long as this connection ID is not the same with any other TCP/IP and UDT connection ID. Okay, so we leave this default. And here, default ADS NAT ID. So now our Siemens PLC will run the ADS protocol, the method behind. So we need to assign this PLC a ADS NAT ID. This diagram here. So my PLC IP address is 1.147 from Siemens side, and I'm going to set up my PLC this NAT ID as this 192.168.1.220.1.1. Okay, I'll copy it, and let's come back here. Let's set it up 192.168.1.220. You assign this as long as they are not the same or conflicts with any other TwinCAT PLC NAT ID address. Okay, so we set up this. Okay, now these two parameters are very, very important. If you recall from this IP address, so our target TwinCAT PLC address is 1.199, and the NAT ID is 1.210. Okay, 1.1. Okay, now we need to set it up. Okay, back to Siemens side, this remote IP address. This is your target TwinCAT PLC IP address. Okay, in this case, because I'm using my computer, my laptop running as TwinCAT PLC, so their IP address is same. So 192.168.1.199. Okay, and again, in the real case, this IP address is your TwinCAT PLC IP address, not your engineering laptop address. Okay, unless you are using your engineering laptop temporarily running as TwinCAT PLC for testing purpose. Okay, so remote ADS NAT ID, again, it is 192.168.1.210.1.1. Okay, so again, this ADS NAT ID, you can find it from your router, the area from your TwinCAT XAE. Okay, and then the remote ADS port. So default, as we know. So if we set out one PLC project under the TwinCAT, so the all default came from the 851. So I will quickly show where we can find this 851. The default, we can leave this as a default. Basically, it is 851. Then very important, username and the password. This is your target TwinCAT IPC, that PLC Windows system username and the password. So in this case, my TwinCAT PLC, okay, its username is automation, and its password is 1234556. This is my password here, and I will intend to set up this password to a wrong password. I will intend to set up this password to a wrong password. And we can immediately see, so how can we troubleshoot this case? If you cannot set up this ADS successfully, most of cases, it came from this username and password haven't set up successfully. Okay, again, I will turn to set up this password to a wrong password, and let's troubleshoot that. Okay, those are the important connection parameters. Once you set it up, then let's download your controller. Okay, now compile the project and let's download to my target PLC. It browsed this PLC and I'm going to download. Okay, we are downloading. Now let's start up. We can go online. So now actually we can open this PLC DB1 and we can see the parameters. Okay, definitely those parameters now is running. So we can see password 1, even though it is wrong password. Username, it download. Now it is running. Once we run the PLC now, default, all those communication is start running. Okay, and then let's go to the watch list. So from this example list, Siemens also provide this watch list, and we can see all those communication tags like read and write, bool, real, and arrays. They all came from this DB1. The structures, right? All those structures, all those tags are here, and the read, all structures are here. Okay. And this is your real data. You will write and read. So other than this, if we go to the watch table again, and now let's go online. The more important parameter at the early beginning is this. So we can see the current status, error code, and your reset status here. Okay, and if I scroll up, so this ADS read and write case is very important. When the system is running properly, you should be able to see this number is scrolling. So a index from 1, 2, 3, 4, 5 till 59 or something. So if we go to IP3, open it, and this ADS read and write case, it will walk from 0, 1, 2, 3, 4, follow this way till the end, 65. Apparently now it is not working. It's stuck at 1. So stuck at 1, it is here. When this integer, the first cycle here, first cycle is 0, then we write 1 here. Boom. That's why here this ADS RW case, read and write case, is equal to 1. And when it is equal to 1, it jump to this bool write is stuck here. So if we go online, we will see it is showing the busy, and error is showing the error code. And the error code from this write ADS here, it is 9102. 9102. Okay, let's go to the PDF and let's check how can we use this error code to troubleshoot your system. So now let's open PDF and let's scroll down and search the error code 9102. So as we can see, it's telling us the connection was rejected by the Beckhoff CPU username or password may be wrong. It is true because password I set to wrong a password. I intend to do this, right? Okay, so this is the first things I'd like to demonstrate for you. So if you have a wrong password, how can you troubleshoot this? So you go to the variable list, go to this ADS PLC1, this instant DB behind, and monitor this ADS RW case. This ADS W case. Then you scroll down and find out this position. So this is the one. Okay, this is the one here. This RW bool. If we go up, RW bool, it is 1. It is stuck here. Then you'll go down here and check it, what the current status from this function block, write ADS, and search the error code from that PDF. Okay, now let's go back to the DB parameter. I will go offline. This connection, let's correct my password. My password actually is 123456. Okay, and I will download it. This is a start parameter here. So I will firstly download and click this load start value as the actual value. So click this button. So this start value will load as the actual value. So once we operate this, we click this online and we can see now the online value, it is 123456. Okay, now if we go back to this watch table, we can see this number changed. If we manipulate this value to 1 again, let's watch it. So I manipulate this value, boom, set 1. You can see it's changing. However, ideally, this value should change from 1 to 65. But this value, I will set again. Let's watch this value again. 1, 2, 3, 4, 5, 6, 7. Go to 11. And it's stuck at this 11. Stuck here. It cannot go through anymore. Then the solution is, let's go to this function block. Go online. Let's monitor that. So let's see the 11. Where the 11? So 11 means the read and write UaExpert. Let's go to the next point of use. Okay, it is here, this area. Let's monitor it. Okay, 11. Okay, 11, it is here, it's stuck at here. And we can see this busy is true and arrow it is on. And the status is showing A710. A710. Okay, let's go to the menu and troubleshoot that. Okay, A710. So from this status and error code, it is this area. The first letter is A. Then the detail we can see here. The response from the Beckhoff CPU returns an error code. Actually, this error code, the 710, the error code, we have to search this error code from Beckhoff ADS return codes. Okay, let's search it. Let's go to internet, Okay, let's search Google Beckhoff ADS return codes. Enter. And then let's go to ADS return codes. ADS return codes. So that code is 710. 710. Okay, this is a solution how we can identify the error code. So according to this code, it's telling us symbol not found. Okay, this is a common error, a glitch from this Siemens example. So the first time when I was testing this program, I had a trouble on this. And finally, I found the reason. It is because, as we can see here, it is trying to read and write U as integer. U as integer. That means unsigned integer. Okay? It is here. It is here. Then if we go back to TwinCAT area. If we go back to TwinCAT area now, the example variable, it doesn't include unsigned integer. It's missing. We have to add the unsigned integer if we first time follow this same structure. So let's add this here. We need to add unsigned integer, and it is unsigned integer. Okay, this is a new. Okay, let's save it and log in that. Before we log in, we can also double check our PLC. This is the port 851. So if you remember the connection information, the port we set from Siemens side is 851. So this is the 851 where they came from. Okay. All right. So now we will log in. And once we log in, if you recall, now it is stuck at this 11 now. So once I log in, implement this new tag, then we will see this value will go down. Okay. So I will try to set aside this window. Okay, my left side window, it is TwinCAT system, and my right side window, it is Siemens window. Okay, we can see the difference. Now, if I'm going to log in this new tag, it is the unsigned integer, and once I log in, we will see this value will change. Okay, I'll log in, temporarily take it off, and log in. Okay, we will see it's scrolling change from 11 to 12. So why it is stuck at 12? Again, the same problem. Okay, if we check it, the 12, it is unsigned integer. If I log out, we will see actually this example variable, it does not include this unsigned integer. So we will add one more integer for this. So it actually not only missing this variable list is missing some other variable list. I corrected them already. So now I will fix all of them. So totally. Okay, I add these three variables. Keep in mind, if you have to use these three variables, so you need to add here. In addition, from the string, so we can see the string. If we look at this read and write string, if we go to the next point of view, use. And from here, when it's operating the string, we'll see the real variable is expecting is main.plc1 string var here. So however, from the TwinCAT area, from this example, its name is plc1 string only. It actually should have this var here. So we will fix this. Okay, so I will add this var. So let's write the comments. Add it var. Okay, so we fix this, and we also add three variables here. So not only this, it's actually missing two array. One is unsigned integer array. It is this. This is a new. This is the new. This is the also new. It's also missing u integer here. Please add this arrays here. So these are the new added. Okay, now let's keep monitoring this again. So it's stuck as 61 as this unsigned integer array. Now once I log in, So we will see this number is keep changing. That means it's working properly now. And meanwhile, if we look at this variable list, this PLC1.write means we are setting something, and the read area, that means it's receiving something. So from the TwinCAT area, this structure now, from the current program, this example, so Siemens PLC is read and write the same area for this. Okay, in the real case, you can set up the two arrays, one array for read, one array for write, and change slightly for the name. So for example, if we go to Siemens area, change the name like this. Okay, maybe change one for read, one for write. This is just an example. And using this way, the reason why Siemens set up this way is easy for you to verify. For example, this byte. So we can see this is the write area for the byte 0, 1, 55, right? So we can verify this. And this is the read area. This is the read area. Now, if I write a new value, for example, let's write a AA and a BB. Okay, so this is the write array index 0. Okay, byte write array. Okay, we can monitor it. Oh, yeah, so we are monitoring that. So currently, this is the byte 1 and 2. We can also change this display mode to hex. Okay, we change to the hex, and now we can modify this AA and the BB into this two array, this index 0 and 1, and we can modify it. And we can wait for a while because it is cycling, right? So now we can see AABB is right here. Okay, it needs a couple of seconds, basically 2 or 3 seconds. Again, it is because this entire example program is operating this entire array, which is a huge area. So we can see it is huge area data here. In the real case, definitely you do not have this huge area. You just typically pick the bytes, integer, and the real, right? Roughly, that's enough. So it can save a lot of time. So basically, you can bypass some scrolling, modify some of this FB3 read and write to jump over the area for some date type. You do not have to do that. For example, D word, right? Maybe the dent. You do not have to send and read and write for this area. Then you just jump over it and maybe comments out this area. So for example, if you like to jump over here, then once you finish the 58, you can jump over to 60, the string, right? So your circulation can be much faster because now it's doing the job for all. In addition, it also can send the strings. For example, now we can change the string name. I will change to hello world. Change to hello world, and let's send. Okay, we send to and wait for a couple of seconds. We can read back. Yep, we read back. We can see this value read back. And we can also go to here, the string variable, and the hello world is received. All right, again, so this ADS read and write case number is scrolling here is a great sign to show if the system is still live, it is working. And the mechanism from this example program is all those write area is writing the data from the Siemens side to here and then read back. So in the real case, you read and write, typically they are separated. So you can set up the separated array area. So for example, your real array can be set a real W for write and a real R for read, separate to two separated arrays. The important status you can also monitor from here. So as we can see, it is keep counting there. That means this system is live, and behind is using the TCP/IP connection. This is the connection, the status, and the error code showing here. And more specifically, if in case you find this number, this read and write case number is stuck, it's not changing anymore. So you can go to the specific area, you can troubleshoot that. Okay. And meanwhile, if you especially like to test some value, for example, now I have one word try to send to, so I can manipulate this index number 53 and I can send. So your sequential will now run, it directly jump to 53 and write this word, this communication read and write, and jump to there and start working from here, and then do the circulation again. Okay, that means you can leave this structure and you can do some program to do some higher priority communication in case some value is changing. So again, this is the ADS communication supplied from Siemens. And back to here, don't forget, review the document. It has error code, and you just need to download this example program to implement this feature. And don't forget, highly recommend you write down, you copy this entire page somewhere for your troubleshooting in case you find an error code like this. Typically, from the Siemens side, we download the example program, and from the Beckhoff side, it doesn't need any program, the communication program efforts. Literally, you just declare the variables, prepare all the required variables there, and it also could be the array or single variables, bool or integers. And you can set up this without any actual cost. They all software, and you do not have to purchase any actual software for this ADS communication. It's fully for free, and you just need to download the example from Siemens. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.